Hello, welcome to the NSCAS Science test design video. We want to welcome you today. I'm Jeremy Henniger. I'm the Director of Statewide Assessment for the Nebraska Department of Education. We also have one take Kellen Conroy, the Teaching and Learning Specialist at ESU1. He's going to share additional information in the video today. Also with us is Rhonda True. She's actually not going to present, but she is our Enhanced Assessment Grant Coordinator at the Nebraska Department of Education, and she's been doing a lot of work around science assessment across the state for the last couple of years, so she's one of our key contacts. I want to thank Kellen and Rhonda and really all Nebraska educators that have been so instrumental in the development of NSCAS Science assessments. The new NCCRS Science standards really required a paradigm shift, and that includes the way educators all over the country are approaching large-scale science assessments. Nebraska educators from classrooms, buildings, districts, and ESUs have been really integral in the transition and the writing from the writing to the standards to the development of assessment, and we can't thank them enough for pushing themselves and all of us across the state to the new assessment. So today we're going to talk about a couple of different pieces. First, we're going to talk about field testing for 2020 in the spring. Then we're going to go through blueprint and test design a little bit. And then Kellen's going to bring back some NCCRS-S language and connections to the blueprint and available resources. One thing that we'd like to mention is you might want to download the blueprint before you continue with this presentation. So you might just hit pause, go out and get that blueprint that should have been right along with this presentation. And that way you can look at it while we go through the slides today. So first of all, NSCAS Science is census field testing in the spring, right? So census testing means that all students are going to participate. So we need all of the students to participate because what we're really doing is field testing as many tasks as possible. So different groups of students will have different tasks because some of those tasks will work the way we anticipate or the way we planned for them to work, and some tasks will not. Some tasks will quite literally fail in the way that we designed them. That happens in large scale assessment. In the past, though, it's been for individual items as opposed to entire tasks. And so we do have this standalone field test, and by standalone, we mean it's just a field test. In a typical year, we embed our field test questions in the operational test. It makes the test a little bit longer, but it also means we don't have to have two different testing scenarios. Also, why we're talking about two different testing scenarios, also mention the waiver. So we were granted a waiver for this year from the U.S. Department of Education, which basically allowed us to only do one test. If we didn't get that waiver, we were going to continue to test the legacy standards like we have been the past several years, and then we would also have this standalone census field test, which would be burdensome on students, on districts, and so we applied for and received the waiver so that we could kind of leave those legacy standards behind and just kind of focus on the new standards. Additional information then. So the field testing, in field testing, we are really testing the test as opposed to testing students, right? So we're making sure that the tasks and the prompts that have been written for NSCAS Science are really of high technical quality, and they operate the way that they were intended to operate. So really, we're testing the test, and because of that, students, schools, districts will not receive scores this year. You're not going to get any information back. We'll have a lot of information that we can glean from that, and we'll share some of that if we think there's important lessons for the state of Nebraska to learn from what we find out, but it's really just looking at item quality, task, and prompt quality. Also note that scores will not be reported to the public in any way, and they won't be used in the accountability system. So the test design is really task-based, right? So we have a task, it's focused on a phenomenon or a problem, and then there's a series of prompts, right? So multiple prompts, typically 6 to 8 per task, maybe a little fewer, that are all linked to the same phenomenon or problem. They're all grouped together as a task. All the prompts, all the items or questions within the task are at least two-dimensional. We wrote them specifically to be two-dimensional, and there'll be no standalone items or one-dimensional prompts on the field test. It really reflects the proportion of three-dimensional elements, the SEPs, the DCIs, and the CCCs in the new college and career science standards. And we'll talk a little bit about that, more about that as we get to the blueprint. And it really allows for a wide variety of combinations of the three-dimensional elements to make sense of the phenomenon, or to focus scientific thinking around a problem, right? So combining those together gives us lots and lots of possibilities as we combine all three of those dimensions. It's important to note that the DCIs will be at grade level targets. So at 5th and 8th grade, we'll be focusing on the DCIs that are at those grade levels. We'll be not going outside the grade level, and we'll revisit that idea again. It's also important to note that unlike ELA and mathematics for NSCAS currently, the science test is not adaptive. It would take us a long time to get an item bank that we could make adaptive because of the task-based design that we have. So in the near future, it will not be adaptive. There is the possibility at some point down the road in several years that we could look at adaptive design, but not in the near future. It's also important to note, because of the test engine constraints, that students are not able to go back to an item, right? So a student answers a prompt, goes on to the next prompt, they can't go back to that. But what we've done is we continue to bring information forward. So in the task, the visuals, the graphs, the text information, if it's important for the students to have access to that in the next question, we'll bring that information forward. It's also important to note that the information, the graphs, the visuals, all of that information will be on the left side of the screen, and the prompts or the questions will be on the right side of the screens. You're going to get a chance to see that in the sample, the item type samplers, but we'll go over that in a little bit here as well. So the field test length, right? So the number of tasks for each student is about 6 per form, but we have 10 or 11 different forms out there that students are going to be accessing. So many of your students are going to see different tasks in the same room, right? So there's going to be 4 to 5 operational tasks. It's important to note that in operational years, that there'll also be 1 to 2 field embedded field tasks in those as well. So the test gets a little longer, but once again, we do that so we don't have to do 2 tests. We don't have to do a field test and operational test. We embed them. It makes it a little longer for all students, but it's a simpler design in the long term, because we continually have to develop new content for this and all of our tests. And this is the way we've been doing it for a long time. But just know that that's going to be ongoing. So the number of prompts, right, or items or questions, that we keep looking at this language and trying to evolve this language, but there's about 42 per form. There would be about 36 operational prompts, and then plus or minus 2 additional prompts. So one slight nuance this year for the field test is that all the field tests will not be the same length, but they'll be within 1 or 2 prompts from one another. Time to administer. So this is based on the pilot test we did last year. We think that the average student is going to complete the NSCAS field test in about 75 minutes. That is our best guess or best estimate. And so it could be varying in lengths. But as you know, students vary greatly in the amount of time that they take on any test, and NSCAS tests in general. Know that this new science test, right? This new science test is going to be longer than the old science test. And in the old science test, oftentimes we were testing discrete knowledge. Students answered a question, moved on. This time with this test, students are problem solving. They're trying to make sense of the information. It's likely that it's going to take them longer to engage in this test. So expect a large variability. We'll continue to monitor that as we move forward. We did put out additional guidelines for scheduling, and we are recommending 90 minutes and dividing it into 2 sessions for students at the least. The guidelines are out there on the web. You can click on that to get more information. Item type samplers for NSCAS General. Item type samplers are basically our practice opportunities. Those are available December 20th. Opportunity for 5th and 8th graders to experience the test format and design. We encourage teachers to get in and experience that as well. These are based on the pilot test from last year, but they've been updated. And it's really important that students have an opportunity to experience the samplers prior to field test so that we get the best information that we can for the field test. It's really important in general that students try hard on this so that the information, the statistical information we get back is good information for us to know whether they're high quality tasks and prompts or whether we need to throw them out and try something else in the future. So each grade will have 2 practice tests in the samplers and approximately 5 prompts per task. We encourage you to do those, like we said, before the field test this spring. For NSCAS alternate, we have online tools training, or OTTs. Those are available in DRC Insight right now, password access, so you can ask your district assessment contact or your building assessment contact if you need those. They can be printed or the online format, but it's an opportunity for all alternate students in 5th, 8th, and 11th grade to experience that alternate test format. Once again, important for all students to have some access to that, experience it before we get to the field test. Okay, so we want to talk a little bit about the table of specifications, or TOS, versus blueprints. We've decided specifically to use the word blueprints with the new science test, mostly because the old TOS and the new blueprints are very different from one another. But essentially, TOS, table of specifications, and blueprints are synonymous and can be used interchangeably. So it's really, this is the information we're giving you about what's on the test. Selected blueprint, like I said, because of the differences. It's also important to note that blueprints are really about 2 different purposes. One, we use it in test design, right, to make sure that the test is consistent from year to year, and that we're essentially testing the same types of things from year to year, so the scores mean essentially the same thing from year to year. It's also, though, blueprints, we also put them out because transparency is important. It's really important that educators all over the state know what we're testing and how we're testing it. So a blueprint is part of that. The item type samplers are part of that. It's really important that we get this information out there so that teachers understand what we're testing. That being said, the new blueprints are very different from the legacy table of specifications, right? So in the legacy table of specifications, they looked a lot like the ELA and the math table of specifications. We gave you information about the indicators we were testing, how many the item range, right? So we showed you on this one that there was 4 to 6 items and how that was broken down with the indicators. And we also told you at what DOK level that those were being tested at. This is actually a really good example, kind of by accident, but you'll notice that all 3 of these standards were testing DOK 1 in the old legacy test. We're going to be pushing that up into 2s and 3s a lot. And so it's really advancing the rigor and the sophistication, but that's what we would expect because the standards do the same thing. So this was the old legacy TOS. This is an example of the new, right, the new blueprint, and hopefully you have that copy in front of you. So this is 5th grade. It's really important to note that we don't give ranges, right? So since they're not discrete items, we don't say there's 4 to 6 items on structure and properties of matter, for instance. What we've done is try to say how frequent we are going to test these particular concepts, right? So first of all, there is too much here for us to do to test all of it in 1 year. If we did that, if we tried to test all this content in 1 year using tasks, then the test would be super long. Nobody wants that. We don't need to do that to get a good idea of how students are doing. And so we're going to be testing samples of the content each year as we move through this. And so really the first line there, well, first of all, let me say, you'll notice, first of all, that gather, analyze, and communicate evidence is still a big part of this. It's how all of these, the DCIs, the SEPs, and the CCCs are all connected. And then you'll get to the frequency. So frequency, all of these concepts across the top here are going to be frequent. You can expect them to be tested every year, right? So the DCIs, there's going to be some items from those DCIs in 5th grade every year, or from those topics that you see there every year. And so it's important that your students get access to that. Infrequent, we would expect it to be tested every 2 years, and rare every 3 years. But let me be very clear about this. Something that is rare might be tested every 3 years, but you're not going to know which one of those years. So you can't say, oh, we'll get to that later. The SEPs and the CCCs that are in the rare category need to be taught every year. Students need to be exposed to them throughout the grade levels and over time, so that they're ready to engage in those science and engineering practices and those cross-cutting concepts. So you're gonna, it might be the first year that students are gonna be tested on some of those things. So we're talking about how often, but not which years. And we're not gonna tell you that. We're not gonna tell you which years independent CCCs, SEPs are going to be doing that. It's also important to mention that the frequency breakdown here is really based on an analysis of the standards themselves. We broke down the standards and said which of these are the most frequent, and we tried to make sure that those concepts were tested more often. And so it was really a breakdown of that. A couple of things that I want to mention as well. For instance, right here, defining problems and designing solutions are really one SEP. For testing purposes, for assessment purposes, we've broken those apart, because you might ask one prompt that's about asking questions and another prompt that's about designing solutions. Doing one item or prompt that encompasses both asking questions and designing solutions, it might be really hard. We've also done that in constructing explanations and designing solutions. So I got that a little bit backwards, but I think you all know what I mean. Asking questions and defining problems, yeah. And so we also broke those two pieces apart too. Sorry, I mixed those up. So going on, so also in the blueprint document, we included some other information that we really wanted people to have, right? So those blueprints are very different than the old TOSs. So we included this table as well that talks about the topics and how often those topics come across, the progressions of those topics in the grade levels. And so once again, these topics by which we access the DCIs are only being used at grade level. So if you look at this, we're only going to be talking about those in the 5th grade column or the 8th grade column as far as topics go on the test. So for 5th grade, we're only going to be doing structures and properties of matter and energy and organisms and ecosystems, space systems, and earth systems, right? So those are the only topics by which we will access the DCIs. The same will go for the 8th, even though there's additional topics in that grade level. And so those are what we're going to stick to. That being said, it's really important, right, that we look at, and that is a little bit lower than I wanted it to be. So 1 second. So if you imagine that bar is up 1, right? If we look at 13 Earth systems, you'll see that Earth systems, that topic is in 2nd grade, it's in 4th grade, and then comes up again in 5th grade and 6th grade and 7th grade. It's really important that if 2nd graders and 4th graders are not exposed to those topics, those concepts, that content, it's going to be really hard for a 5th grade student to pass this test, to be proficient on this test. there is a natural progression of that information in the standards. And so it's really important that students are exposed to that over time and across grade levels. That being said, the SEPs and the CCCs are also in a progression. They're in grade bands, but they're also in progressions, and that information is linked out there. And so you want to look at that too. If the students are not exposed to the SEPs and the CCCs over time, you're probably not going to get students to be proficient in 1 year on the 5th grade test and then on another year on the 8th grade test. The rigor is going to be too much. The science standards are sufficiently rigorous that you need to make sure that students are exposed to that information all the way along. And now I'm going to turn it over to Kellen. Kellen?
All right, thank you, Jeremy. So with that, we're going to take a few minutes just to look at the language of the Nebraska College and Career Ready Standards for Science and how that language connects to the draft NSCAS Science blueprint that we just got done reviewing and that you have access to via the links from NDE and also the links provided in the presentation. So next slide, please. All right, so when we take a look at this, and the Nebraska College and Career Ready Standards for Science are written three-dimensionally, meaning that included in every indicator is a science and engineering practice, an SEP, a disciplinary core idea, a DCI, and a cross-cutting concept, a CCC. So as we look at the image here that we have on the screen, well, we can see when we break each other down, when we break this down, we can see really what we're asking of teaching and learning in science. So if we take a look at that first section, those science and engineering practices, we really think about those are the things we really want students to do. Within the indicators, those will be bold items. So as you look at your Nebraska College and Career Ready Standards for Science, you're in your standards document and you look at your indicators, those will be items in bold. There is a total of 8 that we use, and those are written as examples within the indicators. So any combination of practices may be used to help students make sense of the problem, make sense of the phenomena, make sense of the content that they're working on. Moving over to the next section, the next dimension of our three-dimensional College and Career Ready Standards for Science, we see the disciplinary core ideas. And the disciplinary core ideas those are the things we want our students to know. Within the indicators, there will be no special text features, meaning these will not be bold, they will not be italicized, they will not be underlined, there will not be a larger or smaller font. These will appear in a regular text and regular font within the indicators. But these are from where our topics, where we start to see those topics, and we can pull the DCIs from in that topic progression, which was shown in the previous slide. But these are the things we want our students to know. And so when we look at the topic progression, we can see that, for example, 5th grade had their topics, 6th grade had topics, 8th grade had topics, so on and so forth. This is where we start to pull that content from. As we look at the bottom section there, the cross-cutting concepts, or the CCCs, this is how we want students to think, the kind of the lenses we would like students to see the science through. In the standards, and as you see on the screen here, within each indicator, these will be underlined. So when we take a look at the science and engineering practices in the indicators, those will be bold. Disciplinary core ideas, there's no additional text features, but the cross-cutting concepts, those will be underlined. And so that's really a code of how we can take a look at how the 3 dimensions work together and communicate together within our Nebraska College and Career Ready Standards for Science. So the draft blueprint that Jeremy referred to earlier also encompasses those 3 dimensions of the Nebraska College and Career Ready Standards for Science, so that teaching and learning and assessment align. However, I know Jeremy mentioned this, it's also just important to note that while the NSCAS statewide science assessment is at grades 5 and 8, K-12 science education is immensely important, and topics included in the K-12 topic progression, which is Appendix A, connect to and build on one another as students progress through their education and through their science courses. Next slide, please. And so when we take a look here, and we also take a look at the sample performance task map, this is also included as an appendix. I believe it's Appendix B in the draft science blueprint. But when we take a look here, it's important that we talk about the language, because as we look at the graphic, we see DCI, SEP, CCC, scenario. There's a lot of information that this sample performance task map communicates. And so the performance task map shows how tasks for the assessment are constructed and how they might fit into the three-dimensional elements. So by having an understanding of our language within our Nebraska College and Career Ready Standards for Science, we can see that SEP stands for Science and Engineering Practice, DCI, Disciplinary Core Idea, and cross-cutting, and CCC, excuse me, is a cross-cutting concept. So when writers will select one or more DCIs, then find that phenomena to match. Other three-dimensional elements are then selected that will support the DCIs and the phenomenon. Finally, the task is written. The task is made up of one or more scenarios and consists of text and or graphics. And each scenario supports one or more prompts, which are pieces that will require a student response. So as we can see, starting with the phenomenon piece, we have two DCIs that have been selected and a phenomenon to match. Then we move to the middle, which is the task bundle. So we really start to see and get a visual of how the three dimensions of our Nebraska College and Career Ready Standards for Science start to work together to elicit student knowledge and understanding. Finally, as we move to the last column there, we see a scenario in which students will be presented with prompts that will help them, that will elicit their knowledge and help them make sense of the scenario. And we can see those pieces as well. So for example, the SEPs, the DCIs, the CCCs, and how they work together in each of the scenarios. Next slide, please. So we also wanted to share some available resources out there for teachers, for administrators, for schools that are looking for additional help and support with science. So there are links embedded in this presentation, and there are also links embedded in the notes as well. So we wanted to make sure that everybody had those. A couple of those things that we'd like to highlight are from the Nebraska Department of Education, the science webpage. That is the first link. The second link is from also the Nebraska Department of Education, but it's the Science Assessment Transition page that includes additional information relating to the Nebraska College and Career Ready Standards for Science and the transition of our assessment from pilot tests to field tests to operational tests. As Jeremy mentioned earlier, there will be updated item samplers for grades 5 and grades 8, and those will be posted, and teachers will have access to those. The teacher's guides. The Nebraska College and Career Ready Standards for Science, we still do have those teacher's guides available. They're on the NDE Science webpage, which is the first link. They currently download as Microsoft Word documents. So once you click on that, you'll find your grade band that you need. Click on the document, it'll prompt you to download. It won't take you to another screen. It will prompt for a download. There's also a link in here for the actual Nebraska College and Career Ready Standards for Science, those standards, which can also be found on NDE's Content Area Standards webpage. Another link in here, which can be found on NDE's website, is the NSCAS Science update. This was from the 2019 Administrator Days presentations, which shares additional information relating to science assessment. And finally, the last link here is a draft NSCAS Science blueprint spreadsheet, and this is via Google Sheets. And so what we see here is this spreadsheet was organized to help make sense of the blueprint, to help make sense of where the DCI, the topics, the DCIs, the indicators, and how our three dimensions are really working together. So as you see, as we move from left to right, we see the frequency column, which aligns to the blueprint. The next column is the Appendix A, the topic progression. So what you see in this column, for example, this is topic 3. From the topic progression. It's page 54 of the standards document. Then we move to the topic. So topic 3 is structures and properties of matter. The next column over is that DCI description. As you can see at the top, DCI I've coded orange, SCP I've coded blue, and CCC I've coded green to align with our graphics that we have in the Nebraska College and Career Ready Standards for Science. What you see in the DCI description are the DCIs that have been pulled from the teacher's guide that we have available for teachers to use. The next column over is the indicator that fits with those DCIs. So we can start to see, now we can start to put the topic number, the title of the topic, the DCI description, and the indicators together so we can start to make better sense of the blueprint and what DCIs, what's some of the content, what are the indicators, how does all this work together. Finally, the last two columns as we move from left to right are the science and engineering practices, the SEPs, and the cross-cutting concepts, the CCCs. What you see on the screen here This is what also aligns with the frequency as noted in the blueprint that was shared earlier and that you would have access to once it is downloaded. So this spreadsheet is available via Google Sheets. There is a link for view only rights there. So once you have the link, you'll be able to view this spreadsheet entirely. You may download it, you may make a copy and use as needed for your district. But this was developed to help teachers make more sense of the blueprint and help make connections between our three-dimensional language that we have in Nebraska's College and Career Ready Standards for Science. So as you do that, there is a tab for 5th grade and there also is a tab for 8th grade. And thinking about where we are for science, this is the slide that we use, kind of the theme when we think about our college and career ready standards for science. And as we continue to learn more about our standards in terms of the language, the organization, the three-dimensional components, we can then begin to make better sense of these elements and begin moving towards figuring out how best to implement our learning into teaching, learning, and assessment practices. And Jeremy, I'll turn it back over to you.
Thank you, Kellen. First of all, I'd like to thank Kellen and Rhonda for all the work that they did. Like I said at the beginning, teachers from all over the state, educators from all over the state have been integral in doing this work and helping us create the NSCAS Science test and where we're going, the standards as well, and all of the support documentation that you'll find out there to help everybody. And so it's really great to have all that involvement. One other thing that I'll mention, and Kellen talked to you about the teacher guides. The teacher guides and the detailed NGSS element descriptions, which were also linked in the earlier slide and the blueprint. And those were main sources for Nebraska educators during task development. So when we brought teachers together to create those tasks, to write those prompts, the teacher guides and that detailed NGSS element descriptions were main sources for those educators to create the tasks that will be on the science assessment. I encourage you to dig into this information. If you have questions, Rhonda's information is here on the slide for you. Reach out, send her an email, call her up if you have questions. She'll help you find additional resources or answer any questions. Thank you for your time, and I hope everything's going well in your classrooms.